Hello. In this video, we are going to discuss randomness. What is randomness? In a statistical context, random means there's no predictable pattern. Okay, so real randomness is actually hard to achieve without a computer or some randomizing device. Let's write that down. As an example of how difficult it is to achieve randomness, let's look at it. Let's take a look at a table here, if I can find it. There it is. So this table contains two rows. One of the rows was, it was someone went through and they predicted what a random pattern of heads and tails would look like for a coin flip. All right, so this is supposed to be coin flips. Oops. All right, so one of these lines is supposed to be a student going through and predicting what coin flips would look like. The other one was supposed to be someone went through and actually did flip coins. And so coin flips, if you actually flipped a coin, is going to be completely random, assuming the coin is well balanced. And so if you take a look at those two, which one looks like it was predicted by a person, and which one looks like it is actually random? And if you look and compare the two, one of the things you'll notice between the two is that the top one doesn't have very long patterns, right? So you'll notice that the longest pattern, I think, is this. Oh, there's three tails, three heads in a row. So there's not very many long patterns in the top one. Meanwhile, the bottom one has numerous long patterns. Tails occurs 3 times, then heads, then tails occurs 5 times, and then heads 4 times. So if you look at that, which one would you guess was the one that was created by a person? It turns out it was the top one. So the bottom one with longer patterns, that is the one that's really random. So we have real randomness for the bottom. And so people are not good at predicting real randomness. They end up, you don't get long enough streaks, when a real person is predicting it. And if you actually had real randomness with coin flips, where there was a 50% chance of each outcome, you are going to get long streaks like this, and a human being does not do a good job guessing that. Okay, and so real randomness is actually difficult to achieve unless you have a computer. The computer can go through and do a pretty good job creating real randomness, and we'll talk about that more in a minute. Or you actually have a randomizing device like a coin that you can go through and flip. All right, one thing that you can use if you don't have if you don't have a randomizing device or a computer, is you can use what are called randomizing tables. These are random number tables. And so what they contain is they just contain 5 digits, in this case, between looks like 0 and 9 that are randomly determined. And so whether these random tables were generated using a computer or whether they were generated by someone who had a 10-sided dice, because there are 10-sided dice and just roll the 10-sided dice a bunch of times, is not made clear. But we can infer it, assuming this is real randomness. Then you can go through and you can use a random number table to simulate real randomness if you don't have a dice or you don't have a computer. The way in which you do that is kind of interesting. So what you can do is, like, let's say that you wanted to simulate coin flips and you didn't have a coin, but you had this random number table. What you could do is you could go through and assign odds to one outcome, say heads, and then you could have evens be tails. So you could say, an odd number represents a head, and then a even number represents tails. And so if you go through and use that, let's just get this out of the way here. So let's make that bigger. So what we can do is we could go through, and so just translate this, right? So we said the odds were heads, and so this first line would become, we'd have heads, heads, tails, and then 9 is odds, so that would be a head, and then 8 is even, so that would be a tail, and so on, right? So you could go through, and then the next block you'd have tails, heads, heads, tails, heads, and so on. So that's one way you could take a random number table like this and use it to simulate coin flips. You could also go through and use this to simulate dice rolls. So this is how to use it, how to turn it into coin flips. You can turn it into dice rolls. So, and by dice, so there are multiple sided dice. There are, 6-sided dice is the most common, but there are 8-sided and 10-sided and 20-sided dice. But when you typically hear the word dice, you go to the default, which is 6-sided dice. To turn this into dice rolls, what you can do is you could make it really complicated, but the simplest way to do it would be to take anything from 1 to 6 and then count that as a dice result, and anything that's not between 1 and 6, you just ignore. So just ignore it. All right. So if we were doing dice rolls, the result would be, so you'd have 3, 1, 4, and then 9 is outside of 1 to 6, so ignore it. 8 is outside of 1 to 6, ignore it. Another 8, again, ignore it. So then we'd get 5, 3, 0 is outside of 1 to 6, so ignore it. 4, 2, 2, 3, 3, 2, 1, 6, and so on. So you can go through and you can use random number tables like this to simulate, lots of different situations, coin flips, dice rolls. It's just a matter of going through and just creatively finding a way to adjust the, the information that to adjust the situation, right? So that's how to do it. Okay, so what if you have a computer? So one piece of information about computers. So computers are actually not purely random. They're random enough, but computers and calculators, they go through and they use a seed number to generate the random outcomes. This is something that's worth knowing. And so if you go through and you enter the same seed number, then you will get the same the same results. And so what does that tell you? It tells you the computer and the calculator is using a formula to generate randomness. And you can't really use a formula to generate randomness. So what that tells you is that computers and calculators are not purely random. It's just highly random. They're not predictable, and for a human being, certainly. But if it's going through and it's using a seed number that would generate the same outcome if you went through and used the same seed again, to generate the random results, then that tells you that it's using a formula, and anything formula based is not purely random. So since computers and calculators use a seed number to generate random results, they're not purely random. However, they're random enough for our purposes. They're going to be highly unpredictable. So just to give you an example, so like what might a computer do? If you go through and you use a computer might go through and use the time in some way to generate random patterns. And so if you go through and you enter the seed number, then it jumps to that specific time and uses that time to generate the random patterns. And so within that time seed, the results will be quite random. But it goes through and it uses some technique, and whatever technique it uses to generate the random numbers, the numbers are random, but the technique itself, the fact that there is a technique to it, tells you that they're not purely random. So it's a difference that is it's kind of slight, but it is kind of an important difference. So because computers and calculators can generate random numbers, the StatCrunch can generate random numbers. Let's take a look at an example. All right, so here I've got StatCrunch opened up. And so if you want to go through and use StatCrunch to generate random numbers, actually, let me just shrink this a little bit just in case. So if you want to go through and use StatCrunch to generate random numbers, you go to Applets, and then there's random numbers. Go ahead and select that. Let's see, do I need to switch over to that window? I don't think so. And then from there, what you want to do is it just gives you some options here. So let me explain what those options are. So if you go through and use, so this is the minimum value. So in this case, I guess the minimum to maximum. So it's saying we're going to generate numbers from 1 to 5. So if you want to simulate like a dice roll, you could go through and do 1 to 6. Okay. And sample size, this is how many random numbers we're going to generate. So right now it would just generate 1 random number. So 1 result between 1 and 6. So this does this idea of with replacement or without replacement can be important when it comes to going through and simulating, trying to represent randomness. The idea is, do we want to go through and so if you were to generate like 10 numbers, well, actually you couldn't do 10 numbers between 1 and 6 without going through and having repeats. But the idea is that you could select this so that you could generate like 3 numbers between 1 and 6, and none of them could repeat. So that's the idea. This option is to allow repeats so that you could get 1 multiple times if you had 3 random numbers. or you can leave it unselected, and then if you generated 3 random numbers between 1 and 6, none of them could repeat. Okay, so this is to allow repeats. And then finally, this was what we were just talking about a minute ago. So with a seeding, if you use a fixed seed and you enter the same seed, it will generate the same random pattern. So a dynamic seed is the computer goes through and randomly selects a seed, and then that seed randomly, generates numbers. And so that's going to get you the most random result. But if you wanted to go through and use a fixed seed, then you could go back and use the same fixed seed again and get the same random pattern. So I think this kind of explains everything here. All right. So anyway, let's do this. So we're going to allow repeats, and then we can generate we can generate 10 random numbers between 1 and 6. So these are simulating dice rolls. Okay, let me check again. Do I need to share that window? I don't think so. It looks like it's visible. All right, so and now you can see these are 10 numbers between 1 and 6. And again, this, like when it comes to randomness, if a human being was going through and trying to guess, there's no way they would guess that you'd get 4 6s in a row. But if you actually rolled dice, you will at times get 4 6s in a row. Okay, so that's how to go through and use Stack Crunch to generate random numbers. Okay. And then finally, when it comes to random number generation, you can use a computer or a calculator or Stack Crunch, or what frequently people do is they actually use a dice or a coin. They actually go through and use some physical system that creates random results. You could have a deck of cards. I mean, deck of cards is also another one that comes up. Okay, so this is all just kind of an introduction to the idea of randomness. What we're going to be focusing on in this chapter is probability. So what probability is it's the measure of how often a random event occurs. So for example, the probability of getting heads when flipping a coin is 50%. Okay, so we're going to go into more about probability in future sections, but there are three different types of probability that that are commonly discussed. There's theoretical, which we're going to talk about in the next section. And the idea behind theoretical probability is the probability if an action were repeated an infinite amount of times. That's as compared to what are the broader term is empirical, which we're going to break up into two different possibilities. But empirical mainly just means experimental. So we're going to have experimental probability. This is probability based upon running an experiment. So for example, you could go through and flip a coin 20 times, and after 20 coin flips, you could give the relative frequency of each result. So you could use the number of heads versus the total number of coin flips, and the number of tails versus the total number of coin flips, and that would give you the probability of getting heads or tails. And then finally, there's simulation. So you could have a computer go through and use a random number generator to flip a coin millions of times, and then the relative frequency from all of those results would be the probability. Okay, and the broader term for these are both empirical because they're based upon an experiment. So simulation is a type of experiment, and then experimental is, a more direct type where you're actually using a physical device to generate the randomness. So we have theoretical versus empirical, and empirical covers both of these two different scenarios. So we're going to focus on theoretical probability in this chapter, and so that's it. That covers this this section. All right. Thank you for watching. See you next time.